Every time you use a pencil, you're leaving behind millions of layers of graphite. But hidden in that gray smudge is something extraordinary: graphene. Graphene is a single layer of carbon atoms, just one atom thick, making it the thinnest material ever created, yet about 200 times stronger than steel. It's almost completely transparent, incredibly lightweight, and conducts electricity and heat better than copper. Graphite, the stuff in your pencil, is just stacks of graphene sheets. When you isolate a single layer, you unlock graphene's superpowers. Imagine electronics that are faster, batteries that charge in seconds, and airplanes that are lighter and more fuel efficient, all thanks to this one atom-thick material. Graphene's unique structure gives it strength, flexibility, and conductivity, making it a true wonder material. It's not just a scientific curiosity, it could transform everything from medicine to energy to technology. The secret lies in how those carbon atoms are arranged. One simple change, and the world opens up. So next time you pick up a pencil, remember, you're holding the future in your hand. From faster computers to cleaner water, graphene's potential is just beginning to be realized. This is the story of how a humble pencil led to a material that could change the world. Let's dive in. Graphene's magic comes from its atomic structure, a flat sheet of carbon atoms arranged in a honeycomb pattern. This perfect lattice makes it incredibly strong. The bonds between atoms are among the strongest in nature. Electrons zip across graphene's surface with almost no resistance, making it a superstar conductor, better than copper. It's flexible too. You can bend or fold it without breaking, yet it's stronger than steel. And it's nearly transparent, letting 98% of light pass through. This combination, strength, flexibility, conductivity, and transparency, is almost unheard of in any other material. That's why graphene is so exciting for everything from flexible electronics to ultra-strong composites. Its atomic perfection is the secret to its superpowers. Imagine wearable devices built into your clothes or touchscreens you can roll up. Graphene makes it possible. All this from a single layer of carbon atoms. That's the power of graphene. For years, scientists believed isolating a single layer of graphene was impossible until two researchers in Manchester changed everything. Andrei Geim and Konstantin Novoselov used ordinary Scotch tape to peel off layers from graphite, repeating the process until they had a sheet just one atom thick. This simple Scotch tape method made graphene accessible to labs everywhere. Their playful curiosity led to a world-changing discovery, proving that big breakthroughs can come from simple ideas. Suddenly, graphene was real, not just theoretical. The scientific community was electrified. Now anyone could study this wonder material. In 2010, Geim and Novoselov won the Nobel Prize in Physics for their work. Their story is a reminder sometimes all it takes is a question and a bit of tape. The age of graphene had begun. From theory to reality, the journey started with a humble experiment, and the world took notice. What can we do with graphene? The possibilities are staggering. In electronics, it could replace silicon, making computers and phones faster and more efficient. Its flexibility and transparency mean bendable screens and wearable tech are within reach. In energy, graphene boosts battery capacity and slashes charging times. Imagine charging your phone in seconds. It can make solar panels more efficient and even turn windows into power generators. Add graphene to materials and you get composites that are lighter, stronger, and more durable, perfect for cars, planes, and sports gear. Graphene filters can purify water, offering hope for clean drinking water worldwide. In medicine, it's being explored for targeted drug delivery and ultra-sensitive disease detection. From gadgets to global challenges, graphene is opening new frontiers. Its debut is just the beginning. Graphene's future is bright, but there are hurdles. Producing large, flawless sheets is tough. The Scotch tape method won't scale for industry. Scientists are racing to develop mass production techniques that are cheap and reliable. Integrating graphene into existing tech isn't simple. It requires rethinking manufacturing from the ground up. Safety is another concern. Researchers are studying how graphene interacts with our bodies and the environment. Responsible innovation is key to unlocking graphene's promise. Despite these challenges, progress is rapid. Every day, new breakthroughs bring us closer to a graphene-powered world. It's more than a material. It's a platform for the next generation of technology. Stronger, lighter, faster, and more sustainable. That's the world graphene could build. And it all started with a pencil, a piece of tape, and a spark of curiosity.